is not coming yet. Okay, it has come. I know. Good one. Good morning. Good morning. Good morning, everyone. Still numbering is good morning, everyone. This is Suraj Singh speaking with Bharat India on this day of April 12, 2021 regarding talk of quality, engineering, everything like that. And it's very important. So title being Civil Field Engineering Designs, Construction Methods, Contracts, AnnexSL Organization, Communication, Coordination, Quality, and on top is quality, which is important for everybody. This is that one, this is something you can say, and then we can say this is another specification and certification. Certification here, and this is, you can say, this is another one, hello, and this is another one, quality file, and this is project file. That's what I can say. Let's move together. Now we understand what I'm talking of. Let's say this is project. I'm talking of project here. Project means proposition. Project means something to be done. Project means a kind of grip on time. Project means a system under quality, for quality, with quality, something to produce in a defined time. If somebody asks me, or if I ask you, define project. What is definition? It's simple to say, simple to answer. We have certain objective to achieve. That objective must be certain, and this objective must be for some duration to achieve, and that duration is defined project period, project duration. When that duration is done, then time of project is over. That objective comes in, we get it delivered by ourselves to ourselves, or by someone to someone else. That project had some start, and that project had some end date. Start date and end date, both dates have some longevity, some duration, which is called project duration, project period. Or you can say manufacturing something, making something, building something, promoting something for permanent use, and when that is done, we can say it's over. And then operation starts, or use starts, or whatever purpose was there, that purpose starts. If it was for occupation starts. If it was for manufacturing starts. Or it was production start. Whatever happens, project term is over. Project term is over. Other term comes in, and that has no duration. Maybe some duration there according to designs. For example, we say facility plants, refineries, other plants, processing areas, processing plants. They are given certain lifetime, which is 30 years minimum, or you can say at least 30 years it should work without any problems, without inviting any problems, and then it can be retrofitted also if it is possible. Same way, buildings are expected to work at least 50 to 100 years. So that period is very much long, you can say. It doesn't mean that you have to break them again. If you can afford to break it or do it again, do it, but that is international laws, natural laws of materials. So what we say, project is something that we have to understand in professional way. Professional way means it's for everybody. It's for everybody to understand definition of project. There must be a commencement date, or you can say start date. There must be an end date or completion date, or you can say handover date, or whatever you can call it, when that work is 100% done. This is called project period, and project itself means after that project is called, asset, or it can be called whatever you can say, our investment by commercial terms, in commercial terms, or you may say it's our economic work we have done, and this one of structures, this one of building, infrastructure, plant, or whatever that adds to our economy, and it starts giving returns. So there is a difference between project and operation. You should keep in mind that operation is limitless, it moves on and on and on, but project means construction. Project means construction, development construction, permanent construction, structural construction, or whatever means whatever type of, there may be irrigation projects, there will be hydraulic structures, water structures, there would be other infrastructures, there will be structures so like buildings, there could be flyovers, there could be anyone, whatever you can say, all involve construction. There is no one that doesn't involve construction, and construction means it involves designs, and designs mean it involves contemplation involves feed and all that, which is a long way to go, long way to study. When I say projects, it's a process. When you say project, when you work on a project, this means we work from a piece of scratch, unwritten paper, and we write on that something. It's called sketch. We can say we are working on a project. Project is ongoing, and project must be finished. You cannot say this project has been going for 100 years. There's no such project in the world. One small room to whole city, to whole industrial city, residential city, or whatever city. It takes time, and that can be called a project. A township can be a project. A small room can be a project. A guardhouse can be a project. A whole project complex can be a project. So there is no way that limits us to define project. There is a way that we can understand in its essence what is project. And when we do understand what is project, in that case we have to understand how to do it. How to do it. That's point we must be aware of, how to do it. If we can do it, we say we are capable to do it. This means we understand what to do. Only then we can do it. That understanding is called handling of this work. Handling of project, how to handle this project. Only a person who knows about that field in which this project exists can handle that. Handle means what? To construct it from drawings to physical being. That's construction. To transform design into physical shape. And it is through what? It is through complete organization. That organization can change materials to design requirement, to design mandate. That mandate given in designs, technical mandate, and all other mandates which are used, and production is done. Production of project is done. Gradually it takes time, and we say yes, it is complete now in each and every respect of designs. Specification is also design. Design is design, structural design, architectural design, services design, or specific design, project design, general design, also specifications, project specifications, general specifications, and of course, international requirement, national requirement. All these, all these aspects cover projects. We cannot take projects for granted. Projects means application of technologies, application of personal efforts, application of common sense, and application of designs. When we talk of applications, it's engineering. When you talk of design application, it's also engineering. Of course, it can be in different branches of engineering. When you talk of construction, it's also engineering. When we produce some machine, manufacture some machine, it's also engineering. So engineering is wider than what you think is. Engineering is wider than what we can think is. In that case, associates are quality. Associates are quality. Associates are other than quality. And we can say quality, again I say, it is in Hindi we call kala, art. In our language we call kala, means art, and I can also call it science. What's wrong with that? If there is a system in art, that system applies. Means in art, if we define some system, logical system, theoretical system, it can also be called art or intellect, natural gift of intellectualism. Quality, I take it that way. Means whatever is required should be done, must be done. Equally means it's equal to requirement. If something is defined, we have to comply with that. If we are not able to comply with that, I cannot call it quality. Compliance to requirement must be a must. It's a must. Why not to comply with that? Question arises. If I am not able to comply with that, do I do justice by my profession, my work? Or what's the reason that I should miss compliance? Yes, there can be one reason. Either I am not sure about compliance, or I lack in knowledge, or I am not well informed about what to comply with. This means I am not able to read it or understand it, or I don't know how to read it. This means I should know what is required. Compliance documents must be known to me, what to be complied with. And there is no one page. There may be hundreds of pages I have to read. In rare cases, thousands. Depends. Because there is no one system, there is no one theory, there is no one practicality, there is no one, you can say, formula that I have to work with. Variance exists there. Variance. When we do projects, it's a combination of various branches of engineering as well as combination of mathematical models, of course combination of work models, combination of practical models, engineering models, and common sense, and on top of that personal attention of that person who is involved. Sometimes personal attention goes beyond quality controls. Quality controls remain there, but personal attention improves it, defines it in a better way. It's not easy to get personal attention everywhere. It's not easy, but sometimes it is done. So when we say quality, quality means compliance plus personal attention, compliance over that, and quality means it should be defined properly. Not only defined, but also should be communicated to those persons who are required, who are responsible for transforming requirements into practical shape. And until practical shape is not achieved, I can't say we have done it. Then requirement is defeated. Our project design is defeated if it's not 100% done. And it's very difficult to get 100% done because thousands, hundreds of hands change. No one person exclusively is responsible. Many people, many persons, many brilliances, and many thoughts. There can be. Why can't there be an error? Yes, there is error. Always there appears to be error. But that error must be detected and corrected. So we can say it's not, we just say systems quality, individual quality, element quality, but is it really what we analyze with or we define with? Quality is a comprehensive system. It doesn't come separately. Quality means system quality. Of course, system should work, but that's not enough. If system is okay, person working on that is not okay. The person will defeat system. It won't comply to conform what was required. And of course, material use. So material won't be used properly. So what then we should do? That's the point where I'm concerned with. Quality is not defined structurally. It's defined comprehensively. It's defined how much you can do out of that. It's defined, can you go beyond the quality? Beyond quality going is not very difficult. One should not be satisfied with achieve quality. Quantity and quality are complementary to each other. It is beautiful if you attain both. Yes, I got this production today, my output is this. And of course, it's quality oriented, quality achieved in, quality filled in. And that person who filled in is individual one or a group. And whatever they use, they studied everything. They complied with that. Studying and complying are actually procedures. It's not easy to study everything because of another enthusiasm. I have to put into execution. I have to tell today, I have to report today how much I have done. That enthusiasm is certainly good, but if it is done with quality, if quality element is ignored, that enthusiasm is nothing, zero. Now we say designs. Quality, if I talk without design, I think I mislead myself. If I say this is quality, this is work, and I keep aside designs, then I keep myself foolishness, I keep myself in foolishness. I am fool if I talk quality and not of designs, because designs is my plan. Designs is my route, it's my road map. It tells me what I have to do in whatever possible work. And it's not only one level of design, all stages of designs, all stages. Design means conception. Design means something to construct. Designs means something to think. Design means something to imagine. Designs means invention. Designs means immersion yourself. Immerse yourself in a sea of thinking, if you can, or a river of thinking, if you can. Both are important. Thinking is an only answer to devise something, design something. Design may not work that way as I think, but idea comes in, and that idea is understood, re-understood. That idea is studied, re-studied, reviewed, and finally we get a level where we can say, no, we have to do it, we have to execute it through construction. And that's where construction comes in. Construction means combination of structures. Combination of construct. It's not structural alone, it's structure in entirety. It's not structural engineering alone, it is all construction. When you say cloth, textile construction, textile factory, what they do? They construct textile. They construct machines. They manufacture. Manufacture or construction, I think, are complementary. Manufacturing also you can say. Construction you can say. Production you can say. After all, something is produced. Something is done. So terminology doesn't make a difference. Actually, results make difference. So you can say construction based on all the stages of design. And construction means all stage constructions. Then we can say all activities. Construction means all activities. It's not simply construction. All activities in construction. And that construction, who gives it? Who understands it? How do you say you know it? If you are a new person, budding one, you may not even understand what I'm going to do. And you yourself don't know because you are not experienced. You will not experience that. So what? That can say. We have to define it. If I am an experienced person, I am going to instruct someone, you have to do this construction. But that someone doesn't know what I have in my mind. Maybe I have a lot of things in my mind, lot of things in my mind. But until I communicate that to that person who is going to do it, I am not going to person myself. That person, other one is going to do it. It's my duty. It's my responsibility and obligation to let that person understand exactly what I want to do. That exactly understanding means I have to give him something, either speech or in writing or reference, what I want to do. That person can do only when that person is exclusively and absolutely clear about my intention. And that intention must be better if it's writing or in demonstration. A person understands what I want to say. If it's a repetitive item, I can explain one by demonstration. That means concern. Or if it's authentic one, means you have to explain in writing what I have to do, step by step. Then maybe call statement. I have to state something. This is my statement, brief statement or elaborate statement, but not like stories. It should be pinpointed, it should be stepwise, it should be bulleted, numbered, what you can say. Other person should know. Of course, that person knows about. That person is not exactly the absolute consider knows nothing. That person experience. That person know how to do activity, but sequences are not known, and what sequences should be there are unknown to that person, which it's my duty to provide that information to that person. And if I can't do that, then I have no right to handle that work, that project. So project activities, you can say, first of all, project itself. Project itself should be defined. What is our absolute procedure to do it? How do we plan to execute it? And that execution statement is very important. Means our proposed work, what we have to do it. But there are hundreds of activities and projects, particularly in structures and buildings, all that, plants, and many others. Those activities must also be defined in clear terms. What we have to do it. We can say we have to define scope. We have to define scope what we have to do for every activity itself. We have to define which references we are going to use. Drawing reference, specification reference, whatever reference we have to define that for purpose of performance. Right? And that should be not challengeable, that should be practical. Then we have to define, you can say, what are safety measures we are going to take. Safety measures, health measures, environmental protection measures, or you can say, whatever you can say, ergonomics we have to do. Of course, it's not defined in every activity for people who are experienced. But those people must be taught somewhere else, if not directly on that statement. There should be a systematic explanation of everything. How to have precautionary measures, how to work safely, how to work keeping good health, how to work, you can say, maintaining environment, working environment, how to resort to precautions. You should not feel any pain, you should not feel any displeasure in your body. Only limited displeasure, reasonable displeasure can be accepted. That's what you say. Safety, health and environment issues, we have to take care of that in the activities. And then you say, okay, fine, which materials we are going to use? That's also very important. If we don't know material, how can we say which materials we brought for the activity? So that material must be defined. And of course, we can say procedure we have to write, method we have to write, what are sequence, what is this? So when we have all the material written, we have to say which machines we are going to use, which equipment we are going to use. Like that, we can say everything should be clearly defined. And it's nothing new. We have to define for every important activity. Yes, if activity is repetitive, we can standardize that method. Okay, this method is general one. It can be used for various activities to this extent. and that all activities we can say method statements are very important in that case, and that's why I say method statement. You have to write methods cleanly, and then we can say performance you need, time you have to say, unchangeable it is, all that we have to do, and ultimately it shall impact cost. If we just spend cost for no standard work, cost goes waste. Whatever material we spend, whatever equipment we spend, whatever workforce we spend, all these are expensive. Expenses of the project, our own superintendence, our own surveillance, we have to maintain, and that must be clearly defined, and that where cost lies in. You cannot abuse cost, you cannot abuse use of material, you cannot abuse machine times. It's all everything. And we can say risks factor also involved. If there are risks involved, we should understand risks. If we don't understand risks, then risk would certainly come in and we don't be able to handle it. Risk means waste of time, waste of money, and waste of known is unknown. We don't know what will happen. We can't foresee. We can't view. This means we don't have any intellect in that case. Means we are not engineers there. We are not supervisors there. If we can't anticipate problems or risks that can endanger our time, that can endanger our cost, and that can endanger our quality. Those risks must be foreseen, and experienced people who have done work in field, they can understand well. It's no big deal, one can understand. So risk must be foreseen, and reliability is ultimate. We have to get whatever work you do, it must be reliable. First, I have to be reliable. What I'm doing, I must be sure. I must be sure that I would achieve it reliably, not by chance. Not by, sometimes say, oh, by chance it happened. No, I don't trust by chance. I trust in fact. Fact. That fact must be clear. That's what engineering is about. Engineering doesn't believe by chance. If you ask a question to engineer, oh, what's the engineer must know what that person did, how that person did, what were decision making activities or routes. I cannot answer, oh, it happened because it had to happen. That's not professional statement. That's not professional answer. You must have logic behind that. That's not scientific answer. Because engineering and sciences are related to each other. We do engineering based on scientific answer, not otherwise. If I'm designing something, I said this is beam bending moment. This force coming onto this beam, and this is supporting systems, and we can find a bending moment. We can find out forces, and we can find resistance in that beam. So that is logical, because we know what loads are coming on that, what load subject to this beam, subject to what loads. Imposition of everything we know, and then we analyze that and design that. So that's logical study, logical work. It can't be challenged. As far as we know, we have a knowledge about that. But if we don't do that, that's called reliability calculation. Reliability work means we can lie on that calculation, we can lie on that product based on that calculation. If material is subject to fine adjustments, if material's use is properly done, we can say this reliability. It should be safe forever. It should serve forever. Forever means whatever duration we fix for that, that's called forever or life. We decide 15 years, 20 years, 50 years, 40 years, or whatever duration is decided for that. It must work that successfully during that period. That's where it lies in. That's where it lies in. So we have to be very careful about this issue. We can't just say, oh no, it is gone. We cannot say that. There's some problem with electricity, I think. Let's put off switch. Better. Electrical problem. Alright. So, sorry gentlemen, there's a light problem. So we have to be very careful in this approach. We have to find our statements rightly and correctly, and we cannot simply depend on imagination. So this is called you can say reliability, and we can say safety, serviceability, durability, other knowledge areas, factors. You can say, you may say safety. Whatever I do should be safe. Whatever we do should be serviceable. It should be durable, and powers or concept, or you can say capacities of other knowledge areas and factors must be inculcated into that work in whatever way. Then we come to analysis, which is also very important process, which gives solutions to us, to everyone. Analysis, and you can say analysis and thinking. If you can think, though think is very common word, but which thinking I am talking is not an ordinary thinking. That's logical thinking. I'm not thinking to buy ice cream or to buy some toffee. I'm thinking to produce something through natural products, which I did not do, which I did not make, which is natural, which is God's work, you can say. I have to use those materials. Even water is God's material, air is God's material, and of course, matters which extract from earth inner portion, that too is material. Everything is given there, and we have to, as an engineer or as an analyst, I have to understand them first. If I can think of them, calculate of them, understand them, and understand our problems, what problems do we have in our activities, how we want to move on that, to what extent I can use those materials, to what extent. It may be whatever, steel, it may be iron, it may be rock, it may be dust, it may be water. Combination of these we have to use in engineering. Engineering is nothing but use of natural resources, natural material, natural sources, and of course use of mind on top of that. So analysis is a lead one, is number one lead, which tells me first, which I use for my own problem. This is my problem, how to resolve this. I say, okay, I think on this, I conduct my analysis, it's called analysis, and there may be number of problems in one work. So I have to find solutions to all them through process of analysis, and then I say, okay, I got answer to this, I got answer to every problem, and that answer is useful, that answer works. That's what I have to do. Now this analysis is actually my teacher, you can say. I can consider analysis as my teacher. Yes, it is teacher. It teaches me, though I use it first and then learn from this. But it teaches me practicality, because I did not know before conduct analysis what I had to do. Now I know what I have to do, and that's where it lies in. When I understand how to do this, I can do it. क्या हो रहा है? क्या हो गया? तो पानी वानी पी ले, पानी पी ले. हाँ? Okay. So I say analysis is my teacher, and I am a student of analysis. I am self teacher. I am self student. You can say that I am studying myself. I study myself. I teach myself. I do everything to me using this process. This process guides me automatically, and it tells me what's the solution of problems. And that solution also through analysis I have to understand. I have to understand that problem. I should understand the solution, and I can say so. Analysis is something which is design, also a part of design. It's a part of design, and before design actually it is. Before we do any design, we conduct analysis in our structures, in our mechanism, because a theory of structure we call it. And before theory, we learn what's material, and we learn material through strength of material. And also we learn applied mechanics, where we know what is mechanism, how we do that. That mechanism also we have to understand. So we can say, if we know theory, we know formula which are based on certain application, certain mechanism, we can conduct analysis of whatever problem we have, provided we know how to analyze that, and we can find solutions. And it's all thinking based, we can say thinking and contemplation and engineering it is ultimately. So we can say we got some reliability there. Now, as we said, I'm browsing this file, which is project organizational management file, so we can reach our last stage we studied. So we studied all this. We were at somewhere, I don't know which part it was, 8 or 9 it was, I think, communication, part 8. Let's see, it was just for a look. Four o'clock in the morning. So we were here somewhere. I think. I think this is an execution of liberation process. Communication channels. We should see this one as execution or implementation process. Execution or implementation process. This is page 20. Client or owner meeting deadlines to release contract documents. I think this was our execution contractor, meeting deadlines. Okay, let's talk of contractor. We're talking here. So we said receipt of contract award. So we got it. Inspection review of documents. We got it. Kick-off meeting. We got it. Announcement of project reference. We did it. Authorization project budget and all that we did it. Then authorizing project manager. Okay, this was all tender stage. Then we had done it already. So we go further. Yes, it is somewhere here, I think. Site takeover, appointment of contractor, start dates, all this is there. Now, following process shall be effected regularly during execution at defined activities interval for initiation as well as for update for revalidation. Now, what we see here, let's understand this first. We were concentrating on this. I'll repeat that. We concentrate on this. Records of all live services. Records of all live services drawings from statutory or local bodies. So this is very important point. We have to consider this now. It's actually very important one, not only important, very important one. It says that let us think of now what it's saying. Records of all live services, drawings from statutory or local bodies, review and diversion procedures of all such services. Now what it says. You see, when we start some project, either it's absolutely new area where there's nothing existing, or it is already in other areas where it is a part of other projects. Okay, say when we construct a house or some other project, some you can say not very big project but medium class project in certain developed area, what we do, in that area there must be services ongoing, water line, electrical line, sewer line, or some other oil line, whatever, fire line, fire service line. There can be whatever type of services available or serving. When we are saying services, live services means this service must work there, that service must work there, and that service that work there, we can say that it's live service. It can't be broken. But how can you know that there exists a service? You don't have details, but service exists. Maybe there is some indication, but we are not sure. So what's procedure in a standard word? That every area existing service or closed service, details must be held by certain bodies, certain statutory bodies or authorities, or someone other who is responsible for that. In many countries there are municipalities, there are local bodies, there are certain development bodies or certain government departments or some other agencies which take care of those existing services. We have to excavate that area. We do not know what exists there. What should be done then? We have to know it because we have no right to break any service, even if it's existing service or it's old one. To know that, procedure says you have to find those services. If you can't find, you have to go to those bodies who are responsible for these services, technically and otherwise. And those services should equip you with copies of those services routes. So records of all such services drawings we have to receive from, that apply to those bodies, and such conditions are also written on your contract or standard conditions of those bodies, that you have to access to them to know whether or no certain services exist in that area. You can't excavate otherwise. That's a very important point. In that case, you can say you have to write to those people, those authorities, and you tell them which area you're working in so that they can provide you details of that area, no service or some service, and this you have to apply in each department: electrical department, telephone department, water supply department, sewage department, or you can say some other service, can be fire department. Means it's called extraction, it's called procurement of record drawings or as-built drawings. Means they must be having as-built data. If we can know otherwise also, then it's okay. Then we have to confirm with them as well. This is existing service, what we should do. We can say record of all services, drawings from statutory or local bodies, and plus review and diversion procedures of all such services. It's a statement here: dissemination of project scope to all relevant personnel and vendors. Now say we do it in this statement, very one-line statement, then we cannot start excavation otherwise. And we cannot start excavation means we cannot start project. So once we know these services exist, we take information from those departments and then excavate and tell them this is status. Those guys come and they tell us whether this is live or dead, or this requires some protection. In that case, we protect it, or this no, you have to divert it, or they divert themselves, and they would divert themselves. Right? So the expenses means depend on whose job is this. That doesn't matter, you have to pay or you have to claim, but it depends. So that service must be known before excavation is conducted and carried out, and that service must be taken care of in each and every respect. That's called record drawing service. You have to manage it, you have to work on this, and it's for all services, all time. I still remember there was one chamber, small chamber, in one of my projects, which we know this, we have to shift it. It's not unknown, but it took at least many months. I moved at least 50 times to that department to shift it. So that takes time, but the contract is contract, you can't do otherwise. So before excavation is done, you have to know all this. And excavation, don't think that it's very easy activity. It's very difficult activity, because you have to do study, site study, and every study to start it. And this application of record drawings or procurement of record drawings itself is very important from every viewpoint. It's very time consuming and exercise that doesn't give any products, doesn't give any output, but this is a must, particularly on complicated areas. And this should be known to everybody, and this can be a kind of, you can say, specific method statement. If we know that something is to be done here, some service is diverted, then you have to deal with that. Either you write statement, give to them, they approve, or they have to come and do it for you, for them, for protection, diversion of that service. It can be big service, it can be small service, it can be dangerous service. In some cases, accidentally people excavate and they face problems, electrical problem, if it's electrical cable, or it's water problem, it's water cable. If this happens, and profession says that there should be no such problem caused on projects, but it happens when there is no organization, when there is no system, it happens in that case. So you can say dissemination of project scope to all relevant personnel and vendors. Now we say correspondences. You see, correspondences is something, it's very complicated to deal with by everybody. Correspondence actually is a concept in itself. It's not easy. Everybody cannot correspond until you know everything. You know about that action. You know what's required, what's not required. Correspondence is not a joke. because you have to answer questions, or your questions are to be answered by someone else. It's reciprocal. You have some problem, you have to raise that problem to someone has to respond to you, or someone raises question to you, you have to respond to you. It depends on your title, your responsibility. Correspondence, respond to something. It could be, it could be in terms of memos, it could be in terms of instructions, it could be in terms of legal instructions, and medium can be written mails, paperwork, or it can be electronic mails, it can be communication by phone, of course with confirmation, or it can be, you can say, whatever writing or minutes or drawings or specifications, or you can say proposals, means there is no end. So we can simply say correspondence means pre-tender correspondence, pre-bid correspondence, bid correspondences, post-bid submission correspondences, awards, and contractual communications, non-contractual communications, ordinary communications. All these are correspondences. We have to correspond, and when we have to say correspond, just don't remove core out of this. Don't think it's respond only. Correspond. Every communication must be studied carefully and taken care of, must be understood clearly and acted upon. That's what it is. So we can say correspondence is very important organ on any project, on whose project you talk of. Correspondence is a must, even if it's in writing, it's in whatever way. It could be audio correspondence, it could be video correspondence, it could be paper correspondence, means whatever way it should be clear cut. Correspondence or communication, you can say, is very important. Subject is very important. I'm calling it subject because it's used in every stage. It's not simple, but it's not difficult as well. It's not simple, it's not difficult as well. It is what I say. We cannot leave everything to something. We have to understand everything. That's the point here. Now, if we correspond clearly, actually I should say corresponding itself is an art. It's concentration. If somebody asks me, what do you mean by correspondence? What do you mean by coordination? Actually, correspondence is a part integrated with coordination, and coordination is above correspondence. Coordination is about communication. Coordination is about contents. Coordination means, you can say, you have to stand everywhere. You have to stand everywhere if you want to coordinate. You can't sit and sleep until you think every detail that is required is available. That's what coordination is. If suppose there are 50 points required, if 2 points are missing, 1 point is missing, then you can't work. You say, I provided you 49 points, why don't you work? But 50th point was missing. It could be important point. That work can't be done. This means there was some failure, even to 1 in 50, on correspondence, on coordination. Who would do that? Coordination is absolute. Should be done. If there is even 1 in 50 or 1 in 100 point missing, work can halt. Work can halt and can cause problem to progress. So when we say coordination, it's very simple word people use these days. He's a coordinator. Yes, he is a coordinator, but does he understand coordination? In projects, coordination is power. Power doesn't mean to suspend someone, no. Power means to keep work timely. I think someone is project leader. That leader may be very busy or maybe not very busy and can correspond, can coordinate. It's good if that person does it. But there's another case. Because coordination is technical field, it is a kind, you can say, a different kind of field. It's a technique in a way that it's not engineering technique alone. It is communication technique. It is a search technique. Why this was not done? Keep an eye on past records where we missed. Why I did not respond on this? This was required to be responded. You must have complete track with you. You must have where I was on this file or in the subject. Means your mind must remember, I have done this. There's been no decision on this. And if decision is not happening, if there's no decision reached, it will certainly we'll miss this one. We'll miss everything here. That mind's really very, very important. I can miss something. Why should I miss? Even single point can cause problem. Like a car you're driving, your truck you're driving. If some, you can say, one tire punctures, can do that. If there's some spare part not working, can drive car. The same thing, your coordination is a car. It's your vehicle. That vehicle can move. It's moving. But are you moving with that vehicle? Even if you control that vehicle remotely, that's also coordination. It means you have to, when you are working on an activity, there should be all informations available pertinent that activity. And if all informations are available, certainly that activity should move if people don't sleep. If person is responsible for that activity doesn't sleep, that's where all requirements must be made available by coordinators. You have no right to say this information is not available. Why this information is not available? That's the point. If it's not available, how can it be made available? That's the job of coordination. It is to be made in time, availability should be made in time, and vision is required for that. You should keep an eye on activities coming in, and you have to make sure that there should be no delay, there should be no erosion on requirement, and at required time we should not say this information is not available, because if we do not care, we will miss it and that activity stops drastically. And one activity stops means sequence would stop. That's a very important point. Those engineers, those people who do not understand coordination, they have to understand it. That is, you can say, vision. Why do we need coordinators? Only for that purpose, that they have to keep an eye on every activity, though they are not working on sites, but not necessarily work on site. You keep insight on everything. You keep insight on every requirement. That's where it lies in. That's where point lies in. Correspondence is an integral part of that. Communication is also an integral part of that. You can say interaction is very much integral part of that. Face-to-face talks is very important part of that. Documentation is very important part of that. Available documents, of course, make it good to understand. And you can say meetings, conferences, debates, research all come to some extent in coordination. And those people who have to do it, it's also very important to interact with them. So you can say here, when we talk of such, you can say there can be side memorandums which inform you something. On this side memorandum means those people who are responsible for this, designers or supervising people, they write to people who do it contractually or otherwise. These instructions, these memorandums comes, we call them memos because just for reminding something, keep in memory that you have to do this. That's very important part. Not all, can't say everything. If there's some specific deviation or there's some specific answer, it comes in form of memorandum. Just keep in mind, it's not a it's not something against someone, but because we try to remind you that that's his requirement. Also, you can say instructions. There can be issued instruction to contractor or to who are working for that job. Instruction should also be available and taken care of because there may be some deviation, there may be some change, there may be anything. There may not have instructions there. Then you can say not only instructions, also engineer's instruction. Engineer's instruction means it's higher level instructions. This instruction is decision instruction. This is a decision made when contractual engineer instructs means this is something concrete. Maybe it relates to variations, money, variations of cost. So engineer's instruction, a kind of legal instruction for which even if it is expensive, it constitutes cost variation. It involves that one. So these are basic correspondence you can say. Then mails. Now it is electronic mails. In past these were letters written, or you can say references sent by engineer to contractor and contractor to engineer and vice versa like that. Now it's world of emails, no problem, it's emails. Statutory it is, legal it is. Electronic mails can be used for that and are frequently used. And phonic discussion confirmations can also be done. Of course, then those people who work, they must be specialists. They must be qualified, educated, competent, capable, consistent, and reliable, which can be discovered only through these CVs, curriculum vitae, which must be known because you may be having degrees, but your experience should be justified one because it is a specific job, and only those persons who have adequate background, adequate experience, adequate competency, so to do job, they can do only. You cannot keep misfits on projects. If I am a road engineer, if I have experience in road, people can't expect me to work on buildings. Same thing means, yes, I know what is road, I know what is building, but experience means you have been doing that. So you know every update on that. Yes, you can know other field also, but it takes time to understand that. Therefore, your CV should be clear that you have experience in this project. Then we can say general meeting minutes. There's meeting at a minute. Why call it minute? Because first of all, it's very small script and it's clear script. Minutely it is. Only write very important points on that minutes for action purpose, and also we refer whose action in that. So general meeting minutes and contractual meeting minutes. See, in every project, contractual meeting is something else. Contractual meeting you can call it, or progress meeting you can call it, or liability meeting you can call it, means you are liable in that. Whatever is recorded in that meeting, that's official. All details what contractor is doing is recorded, what engineer is doing is recorded, and of course how owner is responding to that is also recorded. So it's a specific work, you can say, meeting where people sit, all party people sit, and they decide something. That's good one that it comes on the record. Nobody can run away from that. Record that. Recorded minutes of meeting, call them recorded minutes of meeting. Then you can say specialist meeting. This was for contractual meeting. I said there's some format, some agenda we have to discuss, we have to find. That agenda. That agenda is fixed. There's a lag on that. Agenda is fixed, and that agenda is discussed in meetings, and we have to care about that. Probably in that we can say we talk of what was past, last minute. We talk of business, we talk of progress, we talk of percentage of activities, we talk of safety, we talk of accidents, we talk of materials, what's problem materials, or materials are problem free, deliveries of materials, and we talk of designs, we talk of quality, and we talk of status of progress, we talk of workers, we talk of quantities, and we talk of equipment, and we can talk of whatever defects or no defects. Means there is no standard limit. It depends on what project handled, what project we are dealing with. Depends on that. So it's something very specific, I can say, that we have to read some minutes if we have just to learn from what to do, what not to do. It doesn't mean it should be essay writing. It should be pointed. It should be brief one, but it should convey messages what's required. So you can say contractual meeting minutes, then specialist meetings minutes for a specific purpose, for certain purpose only, not progress, not project purpose, certain item of project or some other serious issue. Can say specialist meetings minutes can be written. And the coordination meeting minutes is very important. Coordination meeting minutes, it's a very important one. Coordination, actually it refers to technical coordination, engineering coordination, or we can say technical and coordination, both. Technical and coordination meeting, generally call it, says coordination meetings minutes. What is that? What I experienced in my career, particularly on buildings, there is no one discipline alone. There are disciplines, structural, architectural, and important are services. Services, whatever services building is going to give, all those requirements must be included in building, because those services are spread, or you can say included in terms of every area, every story. And we have to do, for example, load distribution. We have to do AC design. We have to do plumbing design. And we have to do surveillance, etc., IT, etc., or maybe hospital services are required, or maybe education center, what services are required. Are we coping up with that? Because we can say that those services which are very specific to that building, without which building can't function, can't give satisfaction function, intended purpose can't serve. We have to note that one. Because item is not spread, but it's must. So we have to deal with those services, designs, details, and we have to make sure that this won't cause any problem. Means we have to deal with all those services. We call those representatives from all those subcontractors or specialist contractors, sit with them to ensure they are working in every affair. They are working for materials, they are working for services, they are working for submission, they are working for everything. Those people. When you sit with those engineers, those service people, conflicts are clear, clashes are clear. We know duct route, we know electrical cable route, we know where strunging, where are civil cracks, where are architectural, where are suspension ceiling cracks. And we know where is a problem when machine comes in, heavy machine comes in, or where chiller pumps are placed, how do they clash with each other. Like that, so much piping is there, so much surface material is there. You should very clearly, we cannot allow them conflict. That comes under higher level of communication, higher level of coordination, and it tends to be surprises. That's point here, we value that value that stays where different engineers sit together, talk of problems, and then they resolve those problems together. Material problems, the compatibility of metals of each other, drawings issues, drawings clashes, and of course site issues they discuss there, and they have to procure material similarly in time so that work doesn't stop. And this is under knowledge of that contractor, main contractor, and also under knowledge of consultant or engineer. So that coordination, coordination technical meeting is very important from technical viewpoint, based on which you can say we can make submissions of everything. We can issue minutes so that everyone knows what has to do. And we can say like this, these are you can say maybe you can call them higher level meetings, or you may call them professional meetings, or can say contract related meetings, which are routine meetings, because such services meetings are too long. You have to talk of services in detail. Sometimes it takes many hours. Though it's part of main meeting, but due to reasons people call ups, I can say that we try to avoid that. So we have seen general meetings, we have seen specialist meetings, we have seen coordination technical meetings, and you can say minute them. And then others are, foreman meeting, technician meetings, video conferencing, video records, computer records, work photos, vendors, submissions, approvals. So all these, technician meetings, for example, foreman meeting, these are not regular one, but these are sometimes you have to conduct them, know what they actually intend to say, how they want to operate, how they have to deal with that. That we have to understand. Meeting, people think it costs something, but I say it doesn't cost anything. It saves time. We have to communicate to them, and communication doesn't mean that you have to give in writing, because everybody cannot understand writing. Writing cannot be understood by everybody. There are people in construction field who don't know writing. They do everything. There are. So what I'm saying is, we have to sit with them sometimes. For example, frontline workers like foremen, and of course higher foreman technicians. Then we have to talk to them, interact with them. We have to raise questions and let them raise questions. By doing so, we say that video conferencing, video records, computer records, work photos, vendor submissions and approvals, all these are very important requirements. By video conferencing, we can talk to each other from distance. Video records we can make, computer records we can make, work photos we can make, and we can submit all these. So it's really pleasing one. If you think you're serious and you want to enjoy profession, you have to learn all this. It's not difficult. Now we go to planning. What is planning? Planning. How do you understand planning? Oh.
Planning. Planning. Schedule submission. Schedule submission and approvals regularly. Organization chart, job, role, description of various personal budget cost. Planning. What is planning after all? Is it enough to say planning? Is it okay to say planning? Is it? No, I don't think so. Actually, what we call planning is not planning. In fact, this is scheduling, or you can say this is fixing time for activities, to be very frank. Actually, this is fixing time that we have to do this activity, this date to this date, or we have to do this part of project, this date to this date. A project can be broken into various areas. Broken means on papers. A project can be converted to many projects, and each can be allotted time depending on content or depending on priority. So you can say that there can be, for ease of calculation, a number of areas in every project. But you still keep project date start and project date of completion same. So it depends on how we manage, how we organize various areas. Ultimately, timing is to be controlled. Time factors are important because time loss means cost loss. Quality also relates to time. If you don't give time, adequate time to some activity, you can't perform quality. You are rushing, time you are not using properly, you don't use proper time, you delay. You can say if time is delayed, if time is wasted, costs going out, scores out, and quality can't be confirmed. you are in mad rush of time. So it's planning, you can say, it's, it's control and definition of time of every activity. We generally say, look ahead 6 months, look ahead 3 months, look ahead 1 month, look ahead 1 week. We generally think that way. What shall we do in 1 week? What shall we do in 3 weeks? What shall we do in this period and that period? We always plan. Friends, it's not actually, it's time plan. It's plan that guides us, which is best way for us. It can be, it's best to follow it. But this also tells, it should be in such a way given that material procurement is not effective. We have to consider material points. We have to consider if something else is missing. We have to consider that into our view. And if we don't consider that, we lose here and there. Our plan cannot work if we don't understand activity. Planner must understand activity. Planner must understand value of time. Planner must understand how much it takes for activity. You cannot simply define something unusually. There are some activities which are known well, and there are some other activities which are not known well. You have to find time for that. Some people don't understand, but they plan. They plan their way. They don't have adequate input about that activity, but they plan that way based on their own conception, which does not meet sight person's conception. Everything is not technical. Everything is not, shown in drawing. There are so many aspects, so many activities that are based on your experience. Example, let's take backfill. Backfill. Now, side guy decides to excavate hole. By planning, guy keeps in mind, I have to do one by one. There's a difference now. I think side guy is interested in doing clear job, tidy job, and time-saving job. But planning guy says, gives some, if say, few days only for backfill. But as it's not possible, because I do a lot of work in this, and it's to be filled in a year. This means side guy is well experienced because that person knows what's been done. But planning guy hasn't gone through complete requirement of site as well as specifications. Higher time makes a difference. Then knowledge of specification is extremely important. If I don't understand specification, I can't plan. Means planning is not just paperwork. Scheduling is not just paperwork. It's not blue or colored for paperwork to show on walls. It's not that. Planning is complete conception in mind. How do you want to move on this project? How do you want to move on this project? That you can say. Just I say, root of that. If I know capacity to understand that, as a planner, as a scheduler, I am meaningless. My work is meaningless. Site problems must be kept in mind. Contractual issues must be kept in mind, and specifications must be kept in mind. Planner must have many solutions, must have solutions ahead of what site guy thinks, and that must interact with site guy. Why scheduling is not simply bar chart. It's not simply CPM or PERT. It's much more than that. If you don't have experience in construction, if you don't have experience, you can't be scheduler. You can't plan that. Because engineering world is very big. It's not confined. It's the widest vistas. That is engineering. Cannot be taken for granted. Cannot be. After all, nobody can sit on engineering. You have no right to hold work. And if planner himself or self does not understand, then he has to sit with that experienced person and draw it, use it, design it, plan it, schedule it. Even approval doesn't mean anything if you don't understand how to do it. Yes, there should be organization chart, there should be schedule, submission, then role description of various personal and budgetary costs, etc., etc. Cost controls must be there. Planner should have that much knowledge that there is a delay on site. He can immediately say, delay because of this. Do it or payment will stop. We have to understand planning very well. Until we understand very well, we cannot do anything. That's also a point of brilliance. We have to understand well. Because engineering construction depends on planning. Either you plan yourself or use a planner. It's better if you use it, but question of time, question of workload. So planner must be sound in mind, must have complete ideas, and ideas that are taken from site itself. If I select how to plan, how to do it, I can do it conclusively without any cause. It's very easy. You are given contact data, you have contact timings, you have testing timing at end, you have mobilization time, you know what to do, how much time you need, and you have feedback from all manufacturers, what do they require. And if there is no lead items, you can say there is no such item which can be called non-lead items or item that has to start from beginning itself for procurement. Yes, yeah, others was on time but it's not given. It's not. We must be clear about everything in this. So I think we should talk of engineering now. I'll go for a few minutes. And I'm back. Meanwhile, you just use it. You can read more on this. Then come back. चलो यार काफी सारे So we can say now, we can continue, and we can say what we are talking of is about engineering design deliverables, submission review, engineering design deliverables, submission review and approval, material submission, approval, drawing submission, approvals, general formal reviews, approvals, inspection approvals, all documents and drawings approvals, registers, technical queries, engineering queries, documents, central control, working and shop drawings, all side issues. So let's now concentrate on engineering. Now actually engineering is engineering, in fact that's one field of engineering. This another kind of engineering which is engineering discipline in engineering itself, means which relates to particularly those items, those requirements which affect work on site. Means engineering to work on site, it is something that without which work cannot be done. It's not engineering discipline in the field, but it is engineering work. Means for work on site, what is result, what result is received, we know that result should be in compliance to requirements, and that results and requirements are related. If results are kept in view, requirements must also be kept in view, and if there is any disparity, there is any conflict between requirements and what we have decided to specify, that must be taken care of. Now what we say, this is actually, we are talking of executive engineering here. This means we have to procure material, we have to do some design work also in support of actual design. We have to review that work also which is designed, and we have to actually take approvals for everything that requires to implement all those engineering proposals in designs. Means material is required, human resources are required, technology is required, drawings are required, works are required, shop works are required, and all this, you can say, we have to submit this for formal approval by that person who is in charge of engineering, who is in charge of project, because without approval of that person who is authority, contractor or whoever is doing that job has to submit all these requirements or what proposals we have to that engineer for approval, and that approval is then granted by owner. So ultimately these products will be used on projects and used by owner. Engineer has to support it. So owner's permission in fact is required, because materials which should be within defined specifications, whatever we have in our contract, or if it's not there, then whatever is proposed or expected. So we have to submit for every item. We are going to use permanent materials. Those materials must be approved by engineer and by owner. Whatever permanent material, I'm not talking of proprietary material or of temporary material, which must also be approved, but those must be approved in principle. But here it is specific. All materials, civil, electrical, mechanical, or whatever discipline, we have to install permanently, include permanently. Permanently means forever. Those must be approved. Civil, architectural, decoration, electrical, mechanical services, CCTV, SCADA, or whatever else, firefighting, whatever else must be approved. And that's a way how to approve it. You know that's very well. There must be a format, material, what material it is, what specification it is, what drawing it is, what make it is, what manufacturer it is it within list defined or it's not within list defined, it's an alternative, and what are test reports, what samples, whatever is available, whatever we can provide for convincing engineer and owner, we are going to comply with your specifications.
with your project details. That's called material submission. It is submitted formally. It's then either after scrutiny by engineer rejected or accepted, or it's accepted provided comments are written. So it's called approved with comments. And if there are approved comments, it requires resubmission until approved status comes in. And also, until you get this status, you can't place order. You can quantify, but you can't place order, procurement order. This means if material submission is not in time, you cannot place procurement order according to schedule planning. So that will hit your progress. That will impact on your procurement. So it's very important one that your material must be submitted in time, proposed materials, and must be approved in time, so that you can go ahead with procurement of that material, either from local source or from overseas source, whatever. And same thing applies to your drawings, because not contract drawings I'm talking. Contract drawings are schematic drawings, contract drawings are direct drawings. In services particularly, in services, you can say you have to convert schematic drawings into working drawings, shop drawings. Shop drawings also we call them, working drawings also we call them, fabrication drawings also we call them, depending on what work is that. So those drawings on same pattern like materials required to be submitted for approval, and before approval is obtained, work cannot be done on site. So material is one part, drawing is another part. Then there are various other approvals. Example is, as I said, you cannot do anything on site unless how to do it is accepted. That's why it's called method statements accepted. Method statement must be accepted. That's engineering actually. That's the way engineering is done. You can't leave it to site people. It's choice. You can't leave it to your choice. It must be an agreement between contractors and engineer. What's best way to do that? And both should agree, and that must be complied with. It's not your choice, my choice, and your choice, someone else. It's choice by everybody. We have to do that. Then it comes to general formal reviews and approvals, inspection approvals, all documents and drawings approvals, registers, technical queries, engineering queries, document center control, working and shop drawing issues. Now there are various drawings, various categories, architectural, structural, services, and many others. There can be conflicting details because drawings are done exchanging many hands. Even if you have BIM means, it doesn't matter. You have to study drawing from that angle, and I think this is coordinator's job. If it can, it's technical one, must be technical engineering one. And also those people work on site, they find problems in job and they can come to coordinator or whoever is there for that purpose. This is clashing or this is not convincing, means we have to change or we have to get clarification of this detail because we are in doubt, or we have to raise some proposal for this. Those you can say technical queries, or you can say those technical queries on site can be raised. Not only technical queries, there can be engineering issues. Basically there's something required, something is given, it's not practically possible, or we have to find alternative to that. So technical queries and engineering queries can be raised from site. These queries can be raised and you can say conflict. We generally call them site technical queries for those items that are conflicting one or which are not giving same, they are not talking same thing. We request for clarification or request for decision making, or we make some proposal, which happens. And those are the site technical queries. I have some that I'll show you sometime else with technical queries, how these are operated. And then of course engineering design queries, you can say. So some major technique, major mandate required operation design, that's through engineering queries. And there's sometimes a center created on big projects or mega projects which deals only in documents control, document center, where through all letters, all coordination letters, all communications, all drawings pass through for purpose of record. That's document controls, particularly in drawings and specifications, very much important. That's it's a huge volume section. All hundreds and thousands of drawings and documents are kept in there. And that's a part of engineering itself, so work and short drawings issues. So what we say, engineering design deliverables, submissions, review and approval, material submissions, approval, drawing submissions, approval, general formal design approval, inspection approvals, all documents and drawings approvals, registers, technical queries, engineering queries, documents and records of working shop drawings. Also, you can say you can include in that as-built or red lines also. All site issues, which you talk of all site issues. There's so many issues on site, means every site, and nobody can limit them. Every day, every hour issues coming. Daily records of works, means keep them concrete records, cube records, formwork records, rebar records, structural steel records, all stores records. So we have to keep them. Daily records which of works, which I have to say daily record of works, of course. First of all, site diaries, or you can say daily job records, which includes completely what happen on site in terms of materials, in terms of work, in terms of approvals, in terms of machines, in terms of people, in terms of contractors, or difficulties, or problems, areas, or temperature, weather temperature, who came to who is cited. In generally, whatever should record from historical point of view of the in future, that can be formatted, that can be written, that can be ordered. And I can say concrete records, it's a very important one. Concrete records are very, very important records. You have to write every record for every. Of course, you have to send these records daily, but also you can make a register for our use. That register must record everything of the country, where concrete came from, what was quantity, what was the grade, and where it's gone to which area, when cube testing is to be done, and what's company, all these reports. Cube register you can see separately. You can say cube register, you can cube records, cube registers, so you can say concrete records, registers, and formwork records can be here. So you either take in one, or you take out this concrete record, cube register, this is a formwork record, this is a report record, or you can say, or BBS, already the structural steel records, all stores record, which depends on the size of project is, what quantity we have, and we have to analyze it in future. And for that we should have records, we keep them. So it's a very important one. It's complete technical work, and also record and concern. We can say laboratory and material testing management or organization. When the laboratory comes into this action, we cannot say it's not physical or chemical laboratory. It is materials testing related laboratory. Laboratory and material testing management or my organization, and engineering training records, method statements, staff personality development, and team building. You can say team building and upgradation, progress. I can say progress hierarchy, or I can say progress. I should say organization, and monthly payment certificates or evaluation, all quality management or records, filing system, quality training records. See, when we talk of material, we talk of every material. Laboratory is a must. You make some, you propose some third-party independent laboratory, or you can have your own on-site laboratory under charge of engineer. So laboratory and material testing management, we see engineering laboratory is very important part of engineering, because generally all materials are tested. If particularly materials like, for example, full range test of aggregate, test of sand, test of cement, test of, you can say, water, test of steel, and test of, you can say, all other materials which are going to be fixed at a time. So material testing is very important. Mega projects, the S+1 subsidiary branch on site itself. You can say material testing is very important. It's part of quality, and it's not only part of quality, part of magnificent arrangement, how to handle material. Soil, even soil is also testing by laboratory. Even on sites, when work goes on, testing can be conducted. Bearing pressure can be calculated. Shear force can be calculated based on testing. And testing, or even whatever excavation we have done, we have to make sure many cases that whatever's given in safe bearing capacity, that must work on site. After testing of formation, it must be made clear that we have achieved this. Project design, if we can't achieve that, so we are on lower strength on site, then whatever buildings we are going to do shall not work. So in that case, until that soil becomes solid or becomes a good one, we have to leave these railways. It's better think. Now, let's talk about laboratory. In this case, engineering training records, method statements, as I said, method statements, a powerful tool for site work. Here in our country, this is not defined. So this is laboratory issue. Then we can say, we can move on to other issues which are method statement. We already explained in staff personality development and team building. Staff personality development is something which must be taken care of because everybody has a right to learn more. And this being an engineer duty to let others have opportunity to learn. Learning and training has no limit. Staff must know more and more because there is no institution as such that one can go and learn. It's only site institution. Their teachers are engineers and they are seniors, staff workers, seniors, foremen, sergeant, and your seniors, who can teach by demonstration, who can teach by giving details to these people, further details, and let them understand. And let them a chance to read drawings if possible, if not all drawings, some drawings. Because work can be learned by learning, by what can be. You can train yourself more and more technically, not necessary that your writing skills, but you have to understand skill. You can read drawing and apply them. You can read dimensions. I've seen people who are expert in reading drawings, though they're not educated well, but they can produce well. Of course, with little guidance, repetitive drawings they can read. There's no problem at all. They can read sections as well. This much they can learn. That's skill development. That's all skill development. Because by doing so, you shall save your own work. And so you will give them responsibility, and you can just you use your time somewhere else and reject their work. So, as progress management and monthly payment certificates, which is of course is a mandate. You have to pay, and if you don't pay, means contract is the right to stop work. That was successful. Team building and progress review and payment, etc. is a very important point. All quality management records and filing system. That's traceable system. Of course, computerized these days. Quality training records. Quality guys keep all this. Means they must record how many talks they make to people who attended, what they learned, were examined or no, or they participated and certified. And it's quality. Quality is a big gun, you can say, big issue, because everybody can't be expected to know everything. But depending on job description, one has to learn. That learning is really very important viewpoint. If we don't do that, we don't do justice to ourselves. Really speaking, it's unfortunate people don't take interest in that. They keep themselves fake. I'm quality guide, I'm not doing execution, I'm safety guide, or that's not valid one. Quality means you are an engineer. You can't say I'm an engineer. It's your job to teach people. It's your job to learn more and more. Just inspection is not job. That's one job on quality control. As the quality is concerned, total quality is concerned, it's not an inspection alone. It's not. So we can say quality training records must be kept. Then execution records, you can say quality training records, so many. ITPs, checklists, inspections, NCRs. You teach all these to those people. You have to tell them what is quality. They must be clear about quality. People do not understand really what is quality requirement. Who is responsible for what? What's job description? How this relates to work? Is it limited or unlimited?
All these points we have to consider. So in HSC training then, all HSC training, HSCs looks very simple. HSC was very difficult one because it leads to accident. It can lead to accidents. Everyone requires its care. Everyone requires its care. So you have to be very, very creative in this. In can say executions. HSC training is very important. It's given everybody has given actually. It's very important. And say accident or injury records must be there. Safety drill must be conducted and recorded. Toolbox talks and start card. People used to understand toolbox talks. Some people are not confused. But it's very important one for use of tools. One should not cause injury to hands or legs by using tool. So we must understand what toolbox talks and start card. All this start card. Safety, task analysis and review technique card it is, and prevention from hazards it is, and keeping site tidy and site safe, incentive awards and safety walks, and best engineers foreman awards, best looking for all this means site conventions means all. Now what happens apart from safety? Already given too many talks in safety. It's available on other videos. All changes on works, very small, it's called very small, but it's very big. Changes on works. After all, what is change? Why? Even though this is a fixed lump sum price, this is defined contract, yet there are some changes, possible changes, due to design reason or due to requirements or due to instantaneous changes or whatever else. There could be impact of cost, there could be no impact of cost. That's different. But changes happens due to clashes. Changes happen due to, you can say, possible non-conformance, or you can say because that time we did not study very well these points in design stages. We started making something. So we can say all changes on works means whatever changes are there to happen due to resolution of classes, or whatever resolution means there may be minor changes or major changes. It depends on there is some design change or whatever. Then we have to record all those changes on drawings or on specifications. Whatever change from deviation, the change from contract means must be recorded in red line markup, and that red line markup must be approved by all, by contractor, by engineer, must be approved, and then after approval this will be recorded, and red line markup where changes are incorporated into original drawings, which will later on be issued as markup drawings or record drawings. You can say red lines we record every change, we approve it, and then we prepare this into as-builts and submit it or record by calling it dossiers. Whatever data sheets are there in dossiers, whatever maintenance, whatever service, All, all documents must be made dossiers, sealed documents others, all certificates, whatever, according to contract, in conformance with the conditions. All non-compliance records, non-compliance NCRs must be closed, and all remedial actions records, punch list, inspection and records, are site walkthrough records. So, all right, sealed documents, all inward certificates, all non-compliance records, all remedial actions records, punch list inspection records, site walkthrough records, snacks records, and their implementation defects records, and rework requirement records, rework inspections, removal of major defects, lessons learned from mistakes, quality audits, reports from external sources, from internal sources. We have to understand this point very well. Means you cannot just run away because you want to run away. Monitoring, that's the important point. Monitoring and updates continuous process during project life cycle. We have gone through so much into details of everything. After all, this is project and we should know complete stages. Generally we call it initiation, then planning, execution, that's all. So we now talk of monitoring and updates, which is a very important part of engineering. Supervision and monitoring are complementary to each other. Actually, supervision is done by worker itself, means who works. That's number one, supervision, but we generally call it execution, and supervision is given to others, engineering staff, our own engineering staff we have, because supervision means you have to check, and everybody comes to check. So, work supervision and monitoring are carried out by all parties concerned. These processes are done as a part of quality assurance or controls, quality operations, schedule controls, progress or status controls, cost controls, applications of various updates, understanding various non-compliances and non-conformances, understanding risk factors and their implication, mitigation of risk factors, etc. This stage is dominant for pinpointing flaws to be flaws occurring to project performance as obstacles, and also we have to move this stage to other person. If you can't keep it constant at 1%, monitoring can't be done by 1%, changes, everything changes. Monitoring means supervision by contractor, supervision by engineer, supervision by third party, everything, and audit also. Supervision and audit are linked together. That's the requirement of specification. ISO 9001. Not only those persons are left, but those persons are coming. They don't get anything. I used to start. That's it. Okay, so we have to pinpoint everything, we have to control everything, and quality must be maintained, that we have to ensure. As schedule control should be clear, we have to understand how much money we are spending also. Then you can say application of various updates, understanding serious, very non-compliance actions, and okay. So we have to understand these points very well, otherwise we miss a lot. This point is not that easy as we're thinking, it's completely monitoring supervision and taking into confidence, earning confidence that whatever work is going on is according to items, cost control, quality control. You can see updates and understanding compliances, non-compliances. We have to understand risk also and their implication, mitigation, risk and time. So we can say here we have to understand all these factors about quality, about supervision, about monitoring, which is the only way, means it continues, there is no fixed limit in this. It is surveillance or it's inspection or whatever it is, means you have to check everything. This is real performance and you have to do it. Obstacles are required to be eliminated or adjusted for measuring plant value of performance or ascertaining measures are decided. So let's understand now what we say deliverables actually. Deliverables. Deliverables or work done. Deliverables work done. What is work? After all, we have to do work on sites. We have to work on office. These are all works for which you are paid. Included somewhere like that. So these are deliverables, means these are services. They are products. So if not complete, it's part of that. All must be taken care of.
So I say all deliverables, it's difficult sometimes to pronounce it. All deliverables or work done are inspected by contractors, project discipline, site engineer, and project or discipline quality engineer in all respects to meet requirements. These deliverables would constitute almost all documents as well that scope requires. These documents require inspections, examination by competent key personnel for submission authorization. All approved works have to be documented in various approved formats. All or part of deliverables in line with agreed test check percentages are inspected by consultants and engineer or contractor's quality engineer. These deliverables would constitute almost all documents as well that scope require. These documents require inspections, examination by competent engineers, key personnel for approval, authorization for permanent reference documentation. All approved works have to be approved. All approved works have to be recorded, or all works have to be approved. There's change, the repetition of word. All works have to be approved and documented in various approved formats and transmitted to executor or contractor for permanent records. All variances are noted, documented, and their adjustments or applied corrective works are documented, actions are documented for records, schedules are regularly revised and updates are done, time baselines are either maintained or revised. Accordingly, cost baseline also is maintained or revised as case would require. Now, what actually deliverables means? What is the work you do? It is inspected and inspected by those who are authorized for that. Site engineer does it and of course inspected. Quality engineer does it and inspected. Quality engineer is considered independent, but of course in some cases, engineer does it or engineer's representative does it. Then there are documents which are signed by them, and these are required. These are required. These are recorded, this document. Then inspections are done, examination is done, then works are approved and documented, and you can say compiled and reported. Well, this is process, but we should not forget one thing. What is the responsibility in this case? That's point of concern. Engineer representative or engineer inspected, quality person inspects, but ultimately this is a kind of, you can say, declaration that yes, a witness we are, this was done. But if you see it's a legal point or it's the obligation point or liability point, it's person contractor, it's contractor who is responsible for this. That's the point of concern. Means it's the responsibility of contractor who is paid for this, that even if work is approved by others, by engineer representative or by engineer or the quality, responsibility still vests with contractor for whatever plus or minus, whatever good or bad in future. That responsibility absolutely shared by contractor. This point we have to keep in mind. That's only, you can say, kind of support. Quality engineer has to inspect and those engineers have to inspect. But inspect what? Inspect something done by contractor. So you can say contractor cannot be relieved in any case by inspection done by quality engineer or by engineer's staff or engineer. Contractor cannot be relieved of any responsibility whatever, not only for works, for all others, even for materials, even for, you can say, whatever else. Ultimately, because contractor commits that it will do this job according to contract documents, according to specifications, and that's why that responsibility cannot be thrashed. This is very important point. So contractor must be clear, contractor engineer must be clear. Whose responsibility is this? That's the point. Whose job is this? That is what we can say is very brilliant factor, very important factor. Good morning to Chaudhary Raju. Namaskar. Hope you are fine. Nice, very, very nice. Thank you very much. So what we say, this one talking application, this engineering, site engineering, works engineering, I'm talking of that. Application is say, application's responsibility goes to those contractor, that one must be understand. So all part deliverables in line with agreed test check percentages are inspected by consultants or engineer or quality guy. Everything is documented, inspected, declared. They are authorized, yet no responsibility. That's the point here. There may be variations, variance. These are recorded. Adjustments applied, corrective actions are taken. Schedule is also regularly revised. Times, baselines are either maintained or revised. Generally, we have to maintain for recovery. We have to maintain by recoveries. It's difficult to time baseline to revise. Cost baselines also maintained. That's a very important point. I come on to approvals a little, Approvals. Now, all site approvals are based on such inspections by various specialists as well as discipline engineers for consultants over inspections done by contractors, engineers. These approvals could be for civil works or for allied services or something else. All tests require approvals, all factory as well as site tests require approvals. Service installations require testing at various fixes, often first fix, second fix and final fixing, followed by testing and commissioning. Work progress. Work progress is measured by planning engineers or can be by quantity engineers or by engineers. It doesn't make a difference, but generally let us say is lump sum fixed price and there's a fixed amount at percentage of work, so that can be fixed by planners. It doesn't make a difference as far as whole work is concerned. Work progress is measured by planners to compare with time schedule. Formula to measure progress has to be agreed between engineer and contractor during post-contracting planning stage. Progress can be actually biased. Progress can be activity-based or cost-based. Actual project status can be defined exclusively with cost reflection of earned project value. Activity-based projection reflects directive status, but activity-based status of progress is helpful to physically control progress, keep line into time schedule. Work changes. Work changes. All changes are issued by engineer. All changes are issued by engineer or consultant in conjunction with client or owner and based on contractor's opinion. Work changes are expected to be within given limits of acceptances. Changes may be required to meet product requirement or to suit function of project or provide. Basic project cannot be changed. Basic project cannot be changed. Certain requirements may be allowed during scope formation charter. All requirements should have been listed in all respects. All requirements should have been listed in all respects. Only oversights or some can say functional only oversights or some functional changes may be added as changes. Keeping continuation of incorporation of changes may not allow project to finish, that be in interest of neither party. It says that yes, you can make some changes but not absolute changes. Some percentage can be accepted provided it doesn't impact on time of completion, it doesn't impact on cost. Generally variations are not permitted, or if permitted it should remain within fixed price. But sometimes it is compulsion due to unknown. When project was designed or started long back, something wasn't understood, wasn't anticipated, but now it is anticipated as required. For that some changes are maybe accepted, provided it doesn't cost, it doesn't impact on contract duration, and that change material is available. It's not simply change because we find later on that material is not available. In that case, meaning of change does not mean anything. There's no meaning of change, it doesn't work. So changes can affect, changes can generate risks, can say. Change, scope change can generate risks for change on time, schedule as well. Changes cannot be made on long lead items, or if necessary to be made, could be made in early stages of project life cycle, not in mid stage or not later. Cost, time and quality can be severely affected by certain changes that need attention by engineer or client. Better to avoid changes to finish project in time. Changes are not welcome by contractor as well as by engineer. So what is say cost, time and quality can be severely affected by certain changes, because cost, time and quality are product's primary requirement. We have to think of that. If really there is a change, there should be done beginning. Avoid later stage to change. We don't welcome it. Contractors cannot welcome it. No engineer can welcome it. Of course, they have to take back money, they have to get returned back, And at that stage, when there's a time to have written back, or maybe by that time, duration of duration of engineer is going to be over, or duration of, you can say investment made on project needs return, and you can't put contractor also into trouble by changing, because it will impact on cost, time, and quality. So we have to keep very serious ourselves. We have to keep serious that time to close our project is one of extremely significant factor. So we should give enough time for it to change, and we should decide and we should not touch that time. So that's the point. It's time to think. It's time. I say certificates. These are certificates. After all, certification. Work payment certificates. Work payment certificates. Details are proposed by contractors, quantity surveyors, or engineers in conjunction with project engineer or project manager, and this is called statement. Work done statement, you may call it, based on which payment statement is made. All works done and all changes approved and carried out are required to be projected on payment certificate document or payment statement document. Work payment certificates are reviewed by engineer or consultants or engineers, quantity surveyors, or whosoever, in conjunction with consultants, project engineer or project leader. Payment certificates are sent to engineer. Payment statements are sent to engineer or client for approval, so that payment certificate is handed to contractor for claims. In case whatever liquidated damage is approved to be recovered should be included on relevant portion of certificate to allow deduction from PC sum. No liquidated damage can be recovered in case an extension has been granted to contractor. Revised time schedule. Revised time schedule. Project managers or leaders, in conjunction with planning engineer, has to propose revised plan as updates to engineer for approval during various stages of project life cycle. Time schedule should be as explanatory as practically convenient and affordable, organizable, manageable. It should be devised in such a way that all stakeholders and personnel involved must be able to understand without any elaborate explanations. All work breakdown structures, definitions, work packages, required resources, etc., should be indicated clearly, leading to cost of package. It is suggested that up to level 5 time schedule would work better on complex projects, and experience says that experience says that. Now, time schedule should be clear. If we enter into CPM, critical path method, or PERT, program evaluation review technique, I think virtually for purpose of those who have to know it, it doesn't work. Bar chart or Gantt chart is just one for everyone to understand because it is simple. Though they don't come all the time to refer to bar chart, they know what's to be done depending on resources, because bar chart can't do anything if you don't have adequate resources, if you don't have adequate workforce, if you don't have timely availability of material, if you don't have timely equipment, or if there's some other problem of approvals or some other problem, even then you can't make up schedule, you can't meet on that. You can say scale is one part, but sometimes for ease of sight or something else, traction itself is changed. But progress doesn't impact, progress is impacted upon, it goes on and on. So time schedule, you can say it's mandate, of course, it's a part of contract. But if progress is maintained on an overall basis, and if there's some deflection or some deviation from required schedule path, it works. It's not rejected as for some. We simply say progress is in line when we say that we are complying with schedule, or particularly S curve. We say okay, we are lagging behind or we are moving ahead in both cases. If you are lagging behind, how many weeks you are lagging behind? If you are moving ahead, how far we are ahead? We generally don't take that credit. We are ahead. We simply say, okay, we are online. So keep a margin for future if there is an error in work. And it should also be it should be level 1 is master, you can say master schedule. Level 2 is giving little details more than that. Then say level 3 is detailed one, or it includes much details of services, and of course 4 and 5 like that. It takes time, certainly, but that is adjustable. So we can say time is much important. It should be clearly indicated. Everyone should be given part of his schedule or whole schedule. Details must be given up to level 5. This depends on how far you are going. Detailed resources must be given whenever required, or also recovery plan, if it is required, should also be taken care of. Now, important point is communication, general communication to those who are responsible for this work, stakeholders. They are responsible finance wise, not contract wise. They are responsible for so many issues. We have to move forward on this. Let us see how can we move. Let's understand how many minutes we have. Okay, no problem. So all comprehensive records from foregoing processes are sent to head office by project lead to apprise stakeholders of progress, project real progress. Status giving steps being taken for further improvements or updates. Some documents required of furnished regularly should be defined in project plan or within company quality manual. These could be scope updates, minutes of meetings, progress reports, payment certificates approved, organization requirements and updates, finances to be arranged, vendors payment issues, cash flow issues, support from other projects, workforce requirements. And you can say, of course, finance to be arranged, vendors payment issue, cash flow issues, support from other projects, workforce requirements, fast tracking of project progress in certain areas due to various constraints, etc. Requirements of financial provisions needed according to updated cash flow is also reflected. Additional resources are required or requested to meet No, you can say engineers communication to client. Well, we can say we are going to some extent. Let's go through all this first, what we have done. We talked of construction, we talked of these, we are talking of these 16 points, you can say. We talked of requirements, reasons, we talked of project requirement and concept, what is requirement, what is, you can say, organization, management, understanding of project, understanding required knowledge areas, its analysis, structure of that. Simple. And what is risk? What is response? What is organization? Meaning of communication and related charter and this charter. You can say communication, which is very important factor. Initiation of charter, how to compose it, what points to include in that. Planning, what is planning, means of that. Then we can say initiation of charter, planning. It's a very important part, planning. What is owner and client and what is contractor? His execution and what are various channels of communications, monitoring, supervision, lessons we learn, completion, etc. We say we understand profession, we understand project, what we understand about. It's the application of our knowledge enriched with advanced skills, organization, environment factors, processes, tools and techniques to deliver specific results or services to client or customer in line with project delivery. But understand that application of our knowledge enriched with advanced skills, organized environmental factors and processes, tools and techniques in we have to understand that knowledge, scope, what actually we have to give. Means these areas are very important for everybody. Which are the rules actually? Applications of our knowledge enriched with advanced skills, organization, environmental factors and processes, tools and techniques to deliver specific results or services to client or customer in line with project delivery, all deliverables requirements through route of project management, a lead, run, execution, executive, execution of. Now these are scope. Number one, you can say what's the scope of project, what's quality, what level of quality you want to achieve, what's time given for that, what's cost, what risk is involved, what human resources are involved, procurement is involved, communication involved, and so many risk factors are also there. You say analysis to understand how to integrate that plan with required knowledge areas. You can say construction project spectrum relevant to civil engineering specialty discipline required in field. What are all the civil engineering industries? Is also given here. Means it's not something that we have to streamline in generality or specific. But to understand essence of project, essence means we are concerned with the movement plus and minus, ins and outs project, but we have to think of everything in a different pattern. We have to think how to deal with that. That's point of concern here. We have to understand that, we can come up with this understanding of a project. In this case, that project management is defined briefly as an exercise of doing total prospective processes. Project organization is defined briefly as an exercise of doing total prospective processes applicable for use to deliver agreed objectives to end user, consumer or client or owner of project. Project is defined as a temporary plan or scheme for a generally permanent existence of some or certain specific objective for a certain and specific purpose or service. Duration of project could vary between months to years and also to decades as well, depending on magnitude of project. Projects can belong to all classes of engineering disciplines, engineering specialties that may affect nation building as well as to meet international requirements. Project organization or management is a broad term used to define project from its inception to delivery stage and maintenance thereafter. After project is delivered, term changes to operation that could be part of maintenance or consumer deliveries or to render regular public service. Project and product are different terms applied to different status. Project is defined as a temporary execution while product is a regular manufacturing process requiring operational arrangements. Continuation or future of products depend on competitive market, economy and products sustainability by adopting further developments. But project is entirely independent of such factor, but to evolve fully supporting system for delivery of requirement so that it can be used as permanent objective successfully to be used as production infrastructural mechanism. We'll see feasibility study, certain ways, certain methods we can say. Feasibility study tells us whether or not proposal can be adopted depending on location, availability or meeting development demands. Feasibility studies take its own time, and after successful completion of studies in consequential declaration of project or schedule, project or scheme demanded suggestions based budget has to be arranged by client or whosoever would be owner of project. Funding is required based on this study as budgetary so that further follow-up process in gross scale can be commenced without provision of budget data and certainty project cannot move further. FEED, which is full form, is front-end engineering design, documents, publication, defining thorough requirements of project designs, technicalities involved and required specifications from designer as well as from contractors. This stage of FEED is too technical, which requires personnel with specialty potential Hundreds of decisions are required as policy of project. Designing of project with schematic details for development documents followed by further bid documents. This stage is subsidiary to feed that requires in-depth technical detailing for purpose of top-liner execution on front. Hundreds decisions are required as implementation of cost-effective scopes. Project deliveries can be made based on thorough studies, decisions making, implementation, monitoring, corrections, updating, reviews, provisions of additional budgets, absorbing or mitigating possible risks involved with whole procedure or project stages, etc. According to management structures, according to organizational structures, specific terms are used to draw support to manage projects successfully in a professional way, though these are not least but exclusively refer to as guiding principles for whatever professional interest to understand what management or organization is all about on whatever small or considerable size project. Project organization or management includes applications of understood knowledge, areas founded on certain technical processes and tools and technique, forms for planned successful execution of all project activities as defined below. Certain knowledge areas within management structures as follows, and which I have seen. These are definitions all taken care of. The purpose of this is that to understand what we are going to do. That's where we can say how it will fit in. That point is very important, interesting, That point is really interesting one. So you can say, okay, you have to do this, means do this. So here I'd like to say, in fact, what we are talking is not project, we are talking quality. That's what we are talking of. We are talking of something very different. Even if this management or there is organization, which should be, in terms of application, that's engineering and contemplation, thinking and analysis and synthesis and reliability, you can say cost, risks and time and methods, as well as construction, quality which has no limits, quality and designs, which you can say essence of whatever we do, whether we deal systems, we deal quality, we deal safety, we deal procedures, whatever we think of, we do it. Every field, every discipline must be quality based, working quality work, thinking. If you think within quality, means we cannot think rubbish, you can say. Whatever standard we think of, whatever we think of this project, what we want to do, we have to think in a standard way, means it must bring in quality format, quality procedure, quality work. It may be work execution, or maybe design execution, or design work, or maybe field. Our mindset should be towards quality, systems, individuals and element, all quality, and designs and constructions are related. You can say method statements and support for that. And time, of course, is essence. Cost is related, reliability, we can say, as many times as safety, serviceability, durability, and other knowledge areas, practice, and synthesis, of course, and thinking, contemplation, application must be effective. That's engineering plus on both ends. To understand like this, it's a very important point to understand, and that's where we stay. And I think we had enough time today. We'll talk continue tomorrow as well, at the other time. So we can say we must have clear idea about projects,
about engineering, about construction, designs, coordination, communication, quality. If we get it, I think it's very important one. If we get it like this, we can benefit from this. Understanding of everything is important, and our objective is to deliver something qualitatively with quality, material with quality, progress with quality, work with quality, everything with quality. Quality is essence here, quality is work here. If we understand this point, we can successfully moderate ourselves and we can say, yes, it is. It's of course, it's of course something to do with something to do that. We can say, yes, it is, it is, it is. So we can now go for a closure of this. We think it will work in. I think I should thank you all for this little interest, of course, because it's long talk, not like before, but even then more than 3 hours. I should say fine. And I understand many of you may be interested, many of you may not be. It depends on your interest, your profession, your outlook, how do you take it. Something is always better and something is not better. That depends on your interest. Sometimes it works, sometimes it doesn't work. But I have in habit to keep constant on my approach. Constant means in efforts. Constant means, of course, releasing what I have in my mind based on experience, based on knowledge. Small knowledge, not very big knowledge. Something should come into mind, it should be processed properly. And that's my intention, is the quality of work. It doesn't mean you are expert in that, but you can think on that. Thinking again and again, again and again is a requirement. If you start thinking normally or specifically, you will find various ways out for problems to be solved. I think, again I say, don't miss time. Life is very short. Nobody knows what your doings shall remain in this world. That's important. Those unknown people will use it. That's also another point. It's not necessary for whom we are targeting, they should use. Those unknown, maybe unknown, but they are not unknown in reality, because they all belong to this world. That's point. It's important. So I select topics like that. Now it's engineering, and not necessary I always talk of engineering. I talk of planning, I talk of projects, I may talk of something else. This is continuation, never changing, of course. I'll come on to safety again, as well as many other topics which are of interest to everybody. When I'm not expert in everything, I'm expert in none. I'm expert in wasting your time, I think. I'm wasting your time probably. It doesn't make much success to me yet. Well, I think whatever you can say. There's no issue on that. Everybody has the right to say something, to think of something, to criticize something. It will make much problematic to me. Yes, it is. It is, of course it is, and we have to think of that. We have to believe that, and with that belief, I will now to skip this talk now. Thank you very much. I think I should not take longer. Stop.